With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given? A solid sphere is rolling down an inclined plane from rest, and a rectangular block of same mass is also slipping down simultaneously from rest on the same plane. Okay, then we need to find whether both of them will reach simultaneously. The sphere will reach first, or the rectangle will reach first, or it depends upon the density of the material. Okay, so if we just make one of the inclined plane, let's say this is our inclined plane. Okay, and there is a sphere which is kept here. Okay, we just place a sphere, and also at the same, just exactly at the same location, we are also having a block. So we are just showing here to be different, but they would be having at the same location. Now initially the initial velocity for both of them is 0. Okay, now for example, the distance would be the same because we need to take the distance to be same to make the comparison. So we can say that S equals to ut plus half at square. Okay, now here we can see that now our initial velocity is 0. Then what would be the time? Time would be equals to, from this equation, 2s divided by a in the square root. What does it mean? It means that acceleration is inversely proportional to time, or time is inversely proportional to acceleration. So from this equation, if acceleration value is high, then time would be low, or if acceleration is low, then time would be high. So we just need to find what would be the value of the acceleration for both the masses. Now this is the block, so it would be just translating. So for the translation case, what is the value of the acceleration? So it would be moving downward with an acceleration of what? Acceleration of g sine of theta. For example, this angle is theta. Okay, so acceleration of the block would be what? It would be g sine of theta. Okay, and if anything, if any of the object is rotating on the inclined surface, okay, on the inclined surface, what is the acceleration? For example, in this case, it is a solid sphere, so we denote the acceleration as es. So acceleration of anything, whether it is a solid sphere, we just write the general formula. Acceleration would be equals to g sine theta in the case of rotation. This is the case of translation. Okay, this is the case of translation, and this is the case of rotation. So the general formula is g sine theta divided by 1 plus I divided by mr square. Okay, this is the formula. This is the general formula for the rotation down an inclined plane. Now in this case, we are having a sphere. So what is the moment of inertia for a sphere? We just first write the numerator, g sine theta divided by 1 plus. So for the case of a sphere, moment of inertia value is 2 by 5 mr square. So we just write 2 mr square divided by 5. And here there is also mr square. So we put mr square here. So this and this would be cancelled. So it would be 1 plus 2 by 5. So if we take the LCM would be 5, then it would be 7. So we can just write this value as 5 divided by 7 g sine of theta. Okay, because in the numerator it would be 2 plus 7. Okay, so one acceleration of block is coming out to be g sine of theta. Okay, and acceleration of the solid sphere is coming out to be 5 divided by 7 g sine of theta. So which acceleration is greater? This factor is less than 1. Here the factor is 1, here the factor is less than 1. So clearly we can see that acceleration of block is greater than acceleration of a sphere. So if acceleration of block is more, that means time of this block would be less, because just we have seen less than the time of a sphere. So that means it would come, block will reach first. So which option would be the correct option? If we check which option is the correct option, both will reach simultaneously. Wrong. Sphere will reach the bottom first. Wrong. Rectangular block, this is the correct. Depend upon the density. No, it is not depending upon the density, because nowhere there is a density term here coming. So the correct option would be only C option. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.